So I'm pretty sure we're gonna run into some problems about swing on, or not swing, but stick out on this particular application. If I load this guy into the chuck and we tighten it down as tight as we can, yeah, I don't think anyone's gonna wanna be standing near this thing when we spin it up. And controlling the accuracy of the center axis of this part is going to be super tricky. So in applications like this, we need a steady rest on the backside. So I actually went and bought one for this application because it'd be pretty crazy to actually turn on and spin up all of this cantilevered weight on the chuck. You'd probably wouldn't hurt the chuck, but this can get out of hand if you're trying to machine a flat on it and launch across the shop. 40 pounds at, I don't know, 100 miles an hour. So we don't really want to do that. So I went ahead and bought a steady rest and a follow rest for this mill or for this lathe, and we're going to hook it up and see how they work. So let's do that. All right, so it's time for the unveil of the steady rest and the follow rest from Track Machine Tools, Southwest Industries. This is the manufacturer of my CNC lathe. And for new projects that are coming up, one is with Keith Rucker, working on his Stoker engine, steam engine rod or piston rod. I'm going to need a steady rest, and as well as the new Ram insert for the blown up ultrasonic welder. So here is the steady rest. Let's see if I can, it's probably heavy. Let's see if I can pull it out with one hand. There we go. Let me get it up on the table. Okay. I'll zoom in on it. Here we can hinge open to get the stock in. And then we've got nice ball bearings here, or roller bearings with adjustable alignment. So pretty nice. And here is the follow rest stuck in its expanding foam. Oh, this thing's got some beef to it as well. So the follow rest follows along with the cutting tool on the carriage, and it kind of supports your long spindly stock as you're taking cuts on it. So it prevents really flimsy things from just moving out of the way of the cutting tool as you're moving down the length of the shaft that you're turning. So there should just be two bearings here to counteract the forces of the cutter as it's following along down the shaft as you're turning the part. Yeah, so here we go. So in this case, the stock is my arm and the cutting tool is here, and you can support the cut with these basically these brass bearing points to keep your diameter straight as this thing is following along the back side of your cut. So that's the idea. So we can go ahead and load these onto the lathe next. Okay, I test fitted the follow rest onto the front of the lathe carriage here, and this is where the mounting bolts are for this follow rest. And I noticed that I've got an interference in the back here with this way cover. Let me get the GoPro started here. And so basically the bolt doesn't line up back here. The slot doesn't line up. So yeah, let's see here if you can see how it doesn't quite line up, and I'm up against the sheet metal there. So I fussed around for a little bit, and I realized that my tool post holder, this T-slotted block here, is pushed all the way forward on the cross slide. So I think what I need to do is reposition my tool post holder so that I basically will make it impossible for me to crash my way cover into the back of the casting of the follow rest. So that gap right there. So let me go ahead and readjust this thing, and then we can bolt the follow rest down. Hopefully the steady rest is a little easier than this. So steady rest references the actual ways on the main bed of the lathe with the V and then the flat over here. Similar to the tailstock. Then you clamp everything together with this bottom casting. You don't want to ding your ways by dropping this guy on there. Okay. So now I'm going to pull this clamp up, and the bolt is captive in there, and then I'm going to spin down this nut. So you get this, yeah, you open up this toggle, and then you can flip this guy open. Ugh. Oh, yeah, it's real close to the top of the housing of the lathe here. Here, let me adjust. See how my knob is just, if it had like another 40 thousandths, it would have cleared. Yeah. Oh well, maybe they designed it that way. Yeah, it's a nice stop, so I can just put my stock right in there. Got the old-timey Craftsman. It's probably a 80-year-old wrench from my granddad. Let's get in here and tighten this thing. And I think I can basically center in the stock using the indicator, and then bring these wheels up to the stock. I already measured the diameter or the concentricity of the aluminum extrusion, and it's actually really accurate, within a thousandth. And let's drop this guy in. It's a little heavy, and make sure I don't ding anything. So I'm going to intentionally back these guys off, and then I'm going to manually kind of eyeball center on the chuck. Feels like it's wanting to push on the back bearing. There we go. I'll tighten that down. So not really touching anywhere. Yeah, so we can spin this guy. And to be safe, we'll go ahead and lock the clamp here. It's kind of like a roll cage. Now I'm going to manually spin this thing. I'm not going to turn the lathe on. But I want to check concentricity, so let's move in a little closer. All right, and then we can put an indicator on. It's got a 1-inch travel, and it's an old imperial, yeah, inch indicator. Okay, let's see how out of round we are. Yeah, we're about 30 thousandths out of round. So I can probably just push and pull on this guy. Go to the center of our out of round, which is minus 15 thousandths. Oh, I guess I went the wrong direction. Let's push. All right, so we're zoomed in on the indicator a little better. And I'm just hand moving this this rod around in the chuck, and we're plus or minus 10 thousandths. So if we go there, so that says we want to push on our rod. Hopefully you don't see too much glare in there. But yeah, so now we're plus or minus 5 thousandths. All right, we're back. So I've got two cameras going. I got one looking basically up the end of the lathe, the back side of the steady rest, and then I got the little GoPro on the indicator here. So if we spin, you can see how we've got basically like 2.5 thousandths of run out, and that's about as good as I can get from hand bumping it. So now what I'm going to do is start advancing our rollers until they're just starting to snug up onto the stock. So that's 1, 2, the top one here, just kissing it, and then in the back, this is the hardest one to reach, and that's on it. Okay. So now we'll spin again. You can hear those rollers are in contact, and we are still basically plus or minus 1.5 thousandths. And we're starting to run in a little race into the aluminum there. Yeah, so now it's plus, so 0 to plus 2.5 or so. So this is some general purpose grease here. Yeah, we'll grease our ways there, basically. Just so it's not so nasty sounding. All right, so the idea about the steady rest is we can safely, once I tighten everything down a little better, we can safely start spinning up this aluminum shaft and then face the end off. And you know what, I think I probably should have had the carriage on the other side because I can't actually face it off right now because I got to go through all of that. So I may have to reset up with the carriage way over here. Anyway, but the idea is that we can at least drill a center now that this is safe after we tighten it up a little more. Safety glasses on, camera right in the middle of the ballistic trajectory, and then we'll say turn on spindle forward. And there we go. So it sounds pretty stable. Let me get the GoPro. And I'm going nice and slow so we don't build up too much momentum. Normally this would be a bit higher in RPM. Gonna make a nice deep one here so we got a nice good bearing to keep the part from shooting out. Okay, and there we go. So let me shut off the spindle. And we'll back off the tailstock to basically all the way back. We'll bump out the drill chuck, making sure we're not up against the kick out. Yeah, and then we can push our tailstock forward right up into the live center, just like, or into our center drilled hole. The disadvantage though is I can only face so much of the face because we've got our live center in there now. So I don't know. We'll figure it out. Anyway, let's go ahead and get this guy out of here. Would be the next step. So we can open this. We can back off our bearings from the bottom. Actually, how am I going to get it out? I think I do need to retract the tailstock here so we can get it out. But yeah, it's kind of burnished the aluminum there. Not too bad. Surprisingly round. In fact, you can see the indicator scratch there as well. Okay, so let me grab my wrench. Craftsman. Probably made in the USA. Forged in the USA. That tells you how old it is. And we can pull out our steady rest, being sure not to ding the ways. Now, let that come down. We go ahead and lock that. And then we pull this guy off nice and gently. It's a pretty heavy thing too. Let the Morse taper lock. And we can bring our guy forward right into the tail end of our center drill. Probably wouldn't hurt to lock this too. Okay, so let's spin this thing and see if we're still square. So now we've got our live center engaged in our center hole. And let's see what happens. Okay, so it looks like plus or minus 1/1000ths, but it's not like sinusoidal. So I think we're measuring the concentricity of the aluminum extrusion here, which is pretty surprising how round this this extruded stock of aluminum is straight up from the extrusion mill and the metal store. I haven't turned this at all. I guess I am turning a groove with the indicator tip, but yeah, there we go. One thing to notice is that this guy's not spinning though. It's pretty important that you get good engagement on this thing, because if the Lathe center is not spinning, that means that we are not holding our stock firmly. There we go. So I put a little more tension on the tailstock to make sure that we have good engagement. So let's go ahead and make our RPM 150 and then turn it on. So that shows us how we're doing. It's a lot quieter now that we don't have the steady rest in there. The bearings aren't rolling, but I'm probably wearing out the tip of my ancient indicator there. But yeah, you can see a little bounce, plus or minus 1/1000ths. So I think we're set. And this guy is spinning, which is a good thing. Actually, here's a wide view of the situation. So the follow rest we can still apply if we need to, if we're worried about this shaft flexing while we machine it, but I really don't think we will, because the length to width ratio is not that bad. It's pretty much a solid object. Let's go ahead and turn down as much as we can. That ring that you hear is because my tool's sticking out a little too much. The nice thing about this Lathe center is that it's got a small shank where it engages the part, so I can fit tools in. I've got another Lathe center which is kind of big on diameter, and you can't really get down and face off the ends of stock very easily. So we're going to go right up until we are just close to the Lathe center, and we'll come back out. So that ring is a good example of why you want to keep your tool in close. I may have to adjust that actually. None of these dimensions are very precise requirements anyway. Let's do a finish cut. I'm just manually operating the CNC here with hand wheel jogs. Okay, so we'll tell it Z absolute is the zero of our shaft here. Let's see here. I'm going to go ahead and measure where how much of travel we're going to do, because I'm going to program the feed rate on this CNC lathe. So right now I'm looking at going down to the other end, close to the chuck. And I'd say that's a safe number. So we'll just say 22 inches is going to be our target. And then we'll come in and we'll find we'll skim the surface to just get a rough idea. This stock is nominally 3 1/4 inch in diameter. So there we're touching, so we'll say X absolute. And then I could probably just bring the carriage back just to get an idea of concentricity of this aluminum. Looks like the roundness of the stock varies. Out here at the end where we set up the steady rest, we were right on the money, and we actually knocked the cylinder in for the steady rest out here. So this intermittent cut should go away as we approach the steady rest witness marks there. And you can see how we are getting a full cut there, because that's where we basically dialed in the cylinder and come out to the end. That last little chipping sound was a dent in the side of the cylinder. Okay, so let's stop the spindle and see how we're looking as far as concentricity. You can see definitely that, yeah, I had the steady rest set out here, but down here there's a little bit of asymmetry in the stock. I don't know if that's my setup or the asymmetry in the extruded aluminum. but you can kind of see how it's out of round here, and then over here it kind of, so I think it's twisting, just inconsistencies in the extrusion. All right, it took me a second to remember how to do the power feed. Okay, we're gonna do one, actually power feed, and then we're gonna say, we're gonna move an incremental from our current location, which is basically 0, z minus 22 point incremental inches. So this is 0, and minus 22 goes this direction towards the chuck. And then, let's see, X, let's take 10,000, no, let's take 20 thousandths off on diameter just to make sure we're comfortable with things. So that'll be 10 thousandths on radius or 20 thousandths on diameter. This is a diameter DRO. So let's go ahead and hit feed go. And there we go. I might turn on the coolant too, so we don't bog down the cut. And turn on the coolant. Coolant can get messy at times. Yeah, we were picking up some heat on that. So we are getting some bird nesting. I might want to increase the, ooh, that's a hot chip, the RPM a little bit. Feed rate, we can, let's reduce that to 6, I think, inches per minute. And then power feed, we'll do Z minus 22 inches, incremental set, and then go. That sounds a little better. Now we're breaking the chip a little better on this one. Now our chips are about 2 inches long. So this is a better setup. You can usually, with feeds and speeds, fix this, long stringy rat's nest or bird's nest issue. So right now, if I can grab one, our chip is about that size. So that's pretty good. It doesn't get bundled up. We don't have the ringing either, so I think we got better feeds and speeds here. Basically, as your diameter drops, you need to increase the RPM, so your surface feet per minute that the cutter is taking remains the same. And I think all these CNC lathes do that. A lot of times we can just set this up and walk away, but I don't always quite trust driving the CNC carriage into the chuck direction. So we're just going to hang out and make sure we don't destroy the chuck. So we'll see how our finish looks. So that's a pretty good turn finish. We don't want to spend all day turning this, but at the same time we want a decent looking part. So that's not bad. Let me go ahead and measure the diameters and see where we're at front to back. 3.168, 3.168, 3.1685 on this end. Let me double check down here. 3.1685 on this end. Okay, well that shows that our cylinder is basically not running out, or we've got the same diameter on each end. It's a little tricky with this. Let's see, 3.168 on this end, and 3.1685 on this end. So our cylindrical run out basically is half a thousandth over 2 feet. Since the diameter of our turn shaft is within half a thousandths over 2 feet or 22 inches, fortunately I don't have to mess around with this with cross sliding the tailstock to dial in the position of the live center. If I had to make adjustments, then I'd have to tighten and loosen the 2 set screws, which slide the tailstock on this weigh stand here, and you can see kind of the dovetail, or not a dovetail, but the keyed slide, but fortunately we don't need to. So the the lathe is basically dialed in for front to back turning, which is nice. I don't have to mess with that. $3035. Okay, so I'm going to machine a groove into our aluminum barrel over there that will coincide with this casting groove. All right, full disclosure, I'm not very good with cutoff tools, but here is the cutoff tool that we're going to use. The profile of the cutoff tool, let's see if the camera can follow it. Here we go. Let's see if it'll focus there. So the top of this high-speed steel insert cutoff tool is wider than the bottom. So there's a relief angle so that this tool doesn't get jammed up in your aluminum slot as you're cutting it. You want to minimize the exposure of the cutoff tool. So this tip is what's going to do the cutting. Off camera, I took some more accurate measurements. So this is the shape that we're going to make. 3169 is the current diameter. We're going to do 2 notches, 3 inches, and here is our USB high magnification camera. Okay, yeah, there is the freshly ground tip of the cutoff tool. And the dyno light is sitting on the cross slide, so it's constantly looking at the in focus tip of our cutoff tool. I apologize for the not so great grind, but again, I'm not a full-time machinist. Camera up a little bit. Oh, okay, so there is our aluminum cylinder edge. So as we come in closer, and basically right here, we're looking at the reflection of the cutoff tool into the cylinder of the aluminum, which is a little out of focus, you know, because we're skimming along the edge of the aluminum face there, which is a much larger diameter. But basically, as that reflection gap goes to 0, we are setting the depth of our tool. And what I'm doing is I'm bringing the cutoff tool tip, which is this shape. This is just a high-speed steel cutoff tool, closer and closer to the kind of out of focus aluminum. And then it doesn't hurt to stick like something white underneath, like our drawing here. Yeah, so that shows our gap in real time. And what I'm doing is I'm basically bringing in the cutoff tool until visually that gap gets to 0. Now the next step is I'm going to move back in Z, and then we can set the Z location of the corner of our cutoff tool with a similar process. I usually like to give it a little oil. We may do some coolant, but I don't want to mess up my camera too much. I may have already done that. All right, oh, I also put some white Delrin underneath so that we can get better visual contrast while we're cutting. So let's go ahead and take 169 thousandths off, and let's hope for the best. And 15 at 0, it should engage. And there we go, we're starting to cut. And we will go to 169. That's a pretty good continuous cut that it's doing there. Hopefully I'm not leading off or anything crazy. let's see what we got here for dimension. Feeling pretty good about it. Actually, I already measured it. But I did not touch it up for camera effects. So we're sitting at 3.01, 3.005, depends on how I wiggle it. So I'm pushing right at where the calipers are touching the aluminum, and you wiggle your caliper to get it squared up. And we got 3.0000, so that's pretty good. All right, moving on. So let's go ahead and do that. Let's see if our 0 is still true. Come down. And you can kind of see how, again, this is a review on how to set your tool height. This is a confirmation, so we should be 9.5 thousandths off. Hopefully, this is not rehearsed either. So 4, 3, 2, 1, shaving some oil off. We're at 0 now. You can see we're getting some chunks of aluminum, so let's take another 0.5 thousandths. And there we go. So that was a 0.5 thousandths engagement, and we're shaving off 0.5 thousandths of aluminum. Feel the difference from the roller bearing race to the actual machined surface. So we'll open this guy up. Actually, let me zoom in. Maybe you can see some of the race marks. You can see the kind of the oil berm on each side, and then the race itself is pretty clean. Maybe you can see that. Anyway, all right, let's pull this off. Probably check repeatability on the concentricity of the shaft. So let's set up the indicator here. And yeah, so the steady rest is pretty repeatable. That looks to be about 0.5 thousandths of run out, which is, to be honest, about what we had before. So this is without me adjusting any of the races, and I actually re-chucked this in the chuck end of the part. So that's nice. It's always good to see repeatability in your setup. So I did a test fit on our aluminum cylinder, but I forgot to see that there is a step here at the top of the casting for the old ultrasonic welder. We've got angle of 30 set on the controller. It may be hard to see, but now when I turn the knobs, the tool is going to move at a 30-degree angle, so we can break this corner that we've created. But let's make sure that actually happens. X. So my X number is getting bigger. Maybe hard to see. Actually, I need the GoPro set up. But when I turn this knob, you're going to see how the cutter is actually moving at a 30-degree angle. And then when I come back in, it will follow the path it took, and then stop it where I started to tell it to do a 30-degree cut. See there, it went back to 0. So I'm still turning the knob, but it's not going anywhere. But if I turn the knob the other way, then it'll do the 30-degree cut again. So this way you can clean up your angle, and it doesn't matter. You don't have to worry about overshooting and gouging into your part, because the controller is taking care of all of that. It's just cutting a 30-degree angle every time, starting at the origin where you told it to start cutting to 30. But now I'm going to hit return and get out of 30, or the angle cut, and now I can back the tool out. So that wraps up this week's episode. Thanks for watching the rebirth of our air press here with the machined ram. I'm pretty happy with the results. Next week we're going to, oh hello Sierra. We are going to integrate this now reborn air punch with the new ultrasonic welder and an XY indexing stage at the bottom with stepper motors, as well as the EDM punch that we made in the last episode. All of that is going to go together in a work cell where the robot will punch out discs and load them onto the ultrasonic welder to weld the discs onto a plastic cap. So please stay tuned for next week's episode, and if you like what you see, please subscribe to the show. Thanks for watching, and I'll see you in about a week. All right, bye.